right, so your mean we said is your average. Okay. You calculate it by adding up all your data and dividing it by how many data pieces there are. Is everybody clear on that? Okay, so remember how to take an average. Right. Median, notice it has Q2 next to it because they're pointing out that it's also the second quartile, okay, or the marker where 50% of the data lies above and below that point. So the median is the middle data point, okay? Not the middle data point in the list they give you, the middle once you've ordered the list correctly. Because remember, the first thing we had the volunteers do that came up here was to order themselves so that then we could kind of decipher what was happening in the data. Okay? And the mode was the piece of data that happened the most. So like the mode for us was 11:30 because that was the bedtime that happened the most. Okay? So remember these words. You guys already wrote some of this down, so that should be fun. All right. So the first thing we're going to do is calculate mean, median, and mode. So I'm guessing that you guys kind of already know how to do this. All right. I just want to make sure that we're all in the same place. So if you need a calculator, you can use your phone calculator if you want to. You can get a different calculator or whatever. So find your mean, your median, and your mode. Okay, here we go. Okay, let's start with the mode because that's what we started with when we looked at our data. In this set of data, what was the mode? 9. Okay, so 9 happened most often. Now, a couple of things. There can be more than one mode of a data set. So we had like 3 11:30 bedtimes up here, right? That's why 11:30 was our mode. If there had also been 3 1 o'clock bedtimes, then the mode would have been 11:30 and 1 a.m. That's okay. All it's explaining is like what's happening the most. Okay? And if nothing happens more than once, you have no mode in your data. And that just means it's all spread out. There's nothing that seems to like stand out. Okay? So we just use mode to tell us like, ooh, is there something that stands out that we see happening a lot? Okay? Then tell me. And if there's not, then just say there isn't one. Okay? All right. Median, once you ordered your data, what was that divider between the top 50% and the bottom 50% of the data? 12. Okay, and your mean, once you averaged all the data, which is kind of a calculator operation, would you 15.8? With a repeating bar over the 8, thank you. Being so exact. Okay? So are we okay with how to calculate mean, median, and mode? Okay. All right, so we just talked about this. If you need to write this down so that you remember, then jot down any notes about this. So how do you calculate the median if a data set has 2 middle numbers? And what did we say? Like if Skylar hadn't been, remember Ms. Dahl was really deliberate and made like a nice number of people, so I had nice quartiles and medians. But if Skylar, if it was an odd number of people up here, so he wasn't exactly the middle, what did we say we would do with those 2 numbers in the middle? Average them, okay? And then the median wouldn't actually be one of your pieces of data. It would just be kind of like you saying, oh, the median's between here, and one piece of the data would fall in the lower half, and one piece would fall in the upper half, okay? So if you need to make a note about that, make a note about that. We also talked about what if more than one number appears the most. We talked about being able to have multiple modes, so it's okay. You just take the one that appears the most. If there's other ones, even if there's like 5 different numbers, they all appear 3 times, write them all down. Maybe those numbers are important to us for some reason. Or it could have no mode. So if you need to make a note about that, make a note about that. All right. So, Scarletts Question. Are you guys okay over here in this group? Yeah. Okay. Scarletts Question. Why do they call it a box and whisker plot? Because once we take all that data, so you saw the data all standing up here, right? And we talked about minimums, maximums, quartiles, medians, all of this. This is how we visually represent the data. So the reason it's called a box and whisker plot is because you have this boxed area, and then you have this other area with the whiskers, okay? Why they don't just make it a box with lots of bars in it? We'll get to it when we talk about like the interquartile range and stuff like that. I think they're just trying to separate the data. Okay? So this is just like the people standing up here. Okay? This first piece of data is your minimum piece of data. Yeah, sorry. The last piece of data up here is your maximum piece of data. Okay? So all the data is between your minimum and your maximum, just like we saw. This line right here in the middle, that is our median. Or like it was called sometimes, our second quartile. They'll usually call it the median, but it helps your understanding of quartiles if you think like, oh, first quartile, second quartile, third quartile. So this was like Ryan in our demonstration, right? This was like Nick in our demo. This was like Skylar, okay? So then, once we found where Skylar was, we said, okay, I'm not actually having this person step forward because that is part of this lower half of the data. And then we wanted to find the person that split the lower half of the data in half again, and that was our first quartile. Okay? And then this one over here was called our third quartile. Now notice that between the quartiles, again, you want to build that understanding of from the minimum to the first quartile is 25% of the data. From the first quartile to the second quartile is 25% of the data. From the second to the third is 25%, and from the third to the maximum is 25% of the data. It doesn't matter if something looks longer than something else. That's just like Skylar was in the middle, but he was only an hour away from being the minimum bedtime, right? But he was 2.5 hours away from being the maximum bedtime. That doesn't change the fact that the same amount of people were on each side of him. It just changes the fact that he's going to be maybe further from one point than he is from the other, but there's still the same amount of data in this area as there is in this area. Okay? So it's important for us to understand that. Because actually then if we see smaller sections, we think, oh, wow, like a lot of people go between this area because this is still 25% and so is that. Okay? If it's spread out, it's like, oh, that 25%, what's going on with them? Like dysfunctional, right? Like going to here, to here. Okay? All right. The range we talked about. How do we calculate the range? Good. Subtract the lower number from the higher number. So you basically take your maximum minus your minimum, and it tells you the range of data. So it just tells you, wow, all your numbers are going to be spread over this much space. Okay? The box and whisker plot, like we said, is just this picture in its entirety. And then there is something called the interquartile range. So this is kind of visually why it's not all just lines and boxes or dots and lines, I don't know. Why they decided to do it two separate ways is to identify the part that's the interquartile range. So the interquartile range is the stuff that's between the quartiles. Okay? So it's from here to here. Okay? So the entire range of the data, maximum minus minimum says, oh, this data spans, 50 units or something, okay? The interquartile range, you would take the third quartile and subtract the first quartile. Okay, it's ignoring the outer 25% and just focusing on the middle 50% of the data. Okay? So the interquartile range is a range. So it is like a number where you subtracted a maximum and a minimum, but you don't use the actual maximum and minimum of the data. Instead, you use the third and first quartile marks. Okay? Is this okay with everybody? So that vocab? Yeah. Ariana?
So that would then be a number.
Yes. So just like your regular range, it's a number, but instead of telling you how long this is, it's telling you how big this is. Okay? And the way that might be helpful in the future is, let's say the entire range of the data was like 50, but the interquartile range was like 5. That means a lot of the data is happening really close to each other in the middle, and it's those edge percents that are like spreading it really far out. Like maybe like with test scores or something like that. Maybe the person that got the minimum test score, like for example, I had a student flat out refuse to take a test the other day. Like they weren't going to try, nothing. In a class where they don't, I know, I had to leave the room. Okay? All right, so I really did. I just was like, okay, thank you. I had to walk away for a minute. All right, so their minimum score then would be 0 on the test, right? So it would cause this whisker on my box plot to extend really far out even though all the rest of the data might have been really close to where the first quartile was, this whisker is going to be so stinking long because that stinking minimum person got a 0, right? And it's going to extend that really long. So then it might be important for me to know this number, the interquartile range, more than just the whole range of the data because that person's screwing up my data, you know? Okay, and it helps me compare what's really happening. All right, so is this okay for vocab and what everything is? Now this line you see at the bottom is like a number line, and you would have actual numbers here. Like for our bedtime demonstration, the number that would be right here would be 11, right? Okay, and then like Skylar was our median at midnight, and so like that would be midnight. When our maximum was Nick at 2:30, then that number would be 2:30. So you'd have this list of numbers on the bottom, and you're just putting points above it so people can compare it to the numbers. Okay? All right. Okay, so here's an example of data that doesn't have the nice middles that I created by choosing exactly 11 people to come up here. Okay? So you'll notice here that the median of this list of data is 25 because the average of these two numbers in the middle is 25. So these two numbers were both in the middle, so they averaged them. They got 25, and that means the median is like right here. And it is 25. That's not an actual number from our data set. I mean, I get that 25 is a number from our data set, but I'm saying this number 25 doesn't represent either one of these. It's saying the average of these was 25. So notice that this 25 to the right of it is still part of the upper half of the data, and the 25 to the left of it is still part of the lower half of the data. Okay? So then when we look at this half of the data has 6 pieces in the lower half. So again, there's no distinct middle. But these two would be the middle pieces, and if you average 22 and 24, you get 23. So the first quartile is a number between these, which is 23. Okay? Same thing over here, 6 pieces of data. 28 and 30 are the two middle pieces of data. If you averaged them, you would get 29. So again, your third quartile isn't an actual piece of data. It's a number in between them, so it's splitting them up. But notice once it's split, how many pieces of data fall up to the first quartile? 3 in this case, right? How many pieces of data fall between the first and the second quartile? 3. How many pieces of data fall between the second and the third quartile? 3. And how many pieces of data fall between the third quartile and the maximum? 3. Okay? So it splits all the data into equal amounts of data points in each thing, but that doesn't mean they're going to be spread the same. Okay? This quartile right here, from quartile 1 to quartile 2, is going to only go from 24 to 25. It's only going to look like one unit. Okay? Whereas this one right here, the minimum to the first quartile, is going to go from 18 to 22. It's going to span 5 units. So that whisker is going to look longer at the beginning than the next little section, but that doesn't change the fact that 3 of our data points are making up that whisker, okay, 25% of our data, and 3 of the data points are in that little teeny section of the box. Okay, so when we see those smaller sections, we think, oh, like there was more people in this little space. This was the same amount of people, but they were spread out a little more. Okay? So maybe we're interested about why would more people be between those numbers, right? That kind of idea. Does this help clarify? Anybody who is concerned about not having distinct middles and stuff like this should show you. Okay. All right, so now you guys are going to create a box in Whisker Plot. So here's the data from example 1. So you already calculated the median of this, okay? But what you're going to want to do is calculate the minimum. They say lower quartile. That's the same thing as quartile 1 for us, okay? The median, which remember is the same thing as the second quartile. They're saying upper quartile. That was the same thing as our third quartile. The maximum, the range, and the interquartile range, okay?
So is it all 3 of those numbers?
All 3.
Like for each quartile?
Yeah, so you're going to mark your minimum, and then you're going to have quartile 1, quartile 2, quartile 3, and then your maximum point, okay? And there's a number line at the bottom. Once you figure out what your data looks like and you know your minimum and your maximum, you're going to want to make sure your number line is labeled from your minimum value to your maximum value. So when I look up here, that's like 9 to 45. You don't have to number by ones from 9 to 45, but you want to make sure, however you label that number line, that you have enough stuff on the number line to label from 9 to 45. Maybe you want to count by 3s. Okay, maybe you want to count by 5s, and so 9 is going to be marked in between somewhere. Any of that is because there's only 2 numbers. Okay. So, things we should have figured out numerically. Our minimum is 4. Our maximum was 45, right? And therefore, our range was 41. When you ordered the numbers, so you had a 4, 7, 2 9s. Oh, I don't know why that happened. Okay. A 12. What came after 12? 14. Yeah, I don't know what happened. I'm running out of batteries. 14, 18, 24. There's battery in the bed. Okay, so here was our data ordered. So minimum 4, maximum 45, range of 41. So median, what was our middle point? 12. Okay, so 12 was our middle data point. And like Skylar, we had a distinct middle. I really wish I would stop doing this. Oh, not erasing. Okay, I know. I don't care about the one up there. It's not in my way. Okay, so median is 12. Now, since one of our data points itself was the median, we then have it not included in the lower half and the upper half of the data. So there are 4 numbers in the lower half of the data and 4 numbers in the upper half of the data, which means they're not going to have like an exact middle. Okay? Which means what are you going to do when there's not an exact middle? What are you going to do? Good. Find the average of the 2 numbers that are in the middle. So here, 7 and 9 are in the middle, and the average of 7 and 9 is going to be 8. So 8 is what they're calling the lower quartile, or what we would call quartile 1. Okay. And the upper quartile, or quartile 3, is going to be the average between 18 and 25, okay, which ends up being what? 21.5. All right. And then our interquartile range would be 21.5 minus 8, just like we calculate the range, but not from the minimum to maximum, from the upper quartile to the lower quartile. So 21.5 minus 8 is 13.5. Okay? All right, so the way that you're normally going to see these written is that there's going to be a number line. I don't know, say I count by 5s. Okay, and then on your number line, right above it, not connected to it or labeled or anything, you're just going to see this picture that's going to look like that box and whisker plot you saw before. But where they're putting the things corresponds with the number line. So since my minimum is 4, the beginning point would be like here somewhere. Since my maximum was 45, the ending point would be there. My median was at 12. So there's some line in here at 12. My lower quartile or first quartile was at 8. So that would be here. And then my upper quartile was at 21.5. So that would be here. So my box is around that interquartile range from first quartile to third quartile, making sure I've marked the median in between. And then the whiskers extend the lower quartile to the minimum and the upper quartile to the maximum. Okay? So what this tells us about the data, okay? Even though this, like from the minimum to the first quartile and from the first quartile to the median, looks smaller, how much of our data is between 4 and 8? From 4 to 8, how much of our data is there? 25% of our data. And how much of our data is between 8 and 12? 25% of our data. So half of our data is from 4 to 12, but the other half of our data is from 12 all the way to 45. So those numbers must be more spread out in our data set, right? So that's what this is trying to visually tell you. Like 25% here, 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 and here. The longer things you say just mean that those 25% of the data are more spread out, where this 25% of the data is a lot closer together, okay? So if we like drew the data somehow, These ones would be more clumped together. Maybe there's some significant reason why. Okay, why it's landing over there. Okay? Maybe one of those is kind of ridiculous. Right? Do you guys have any idea why, looking at the numbers, you think maybe like a lot of the data is ending up here and why this is so long to get to our 25%? Numerically, so if you look at the numbers, does anything seem out of place, or the 45, so it seems a little bit ridiculous, okay? And we can see it both visually and numerically, right? In the numbers, 45 doesn't seem to fit. It seems significantly larger than a lot of the other numbers that we have up here. And then when we look at then the spread of our data, how it's spread out, these are also nice. This is a little bit longer, but not too bad. And then this is just ridiculously long because of that 45 that's out there. So we're going to talk in a little bit about how we can see if that's affecting our data. All right, we're going to skip the practice one for now because we'll come back and do that again tomorrow. All right, so we just talked about the 45. So we might think, because of the way the 45 is affecting our data, we looked at it number-wise, and number-wise it didn't seem to fit with the other numbers that were there. Okay? Then besides that, we looked at the visual representation, and in the visual representation, it seemed to be skewing our data, right? It seemed to be dragging part of our data out a lot longer and really affecting what our picture was looking like. So we might feel like the 45 is something that we call an outlier, okay? So an outlier is a piece of data that doesn't belong in your data set or is skewing your data, okay? So you're going to want to write that down. So an outlier is like a piece of data that does not belong in your data set. The way you know this is it is skewing your data. Okay, you can see either by the numbers or by the way you're graphing it that that one piece of data is a pain in your butt, okay, and it doesn't belong there, and maybe you just need to throw it out, okay? And we all saw this happen yesterday when we took our beautiful little survey, okay, and we saw the beautiful person that wrote. They were underwater basket weaving, and they spoke 0 languages fluently, and all of this kind of stuff, right? Okay? So that, for us, is probably going to be an outlier because some of that doesn't make sense. I don't know how you would be sitting here if you didn't at least speak one language fluently, okay, as a 12th grader in high school. So, okay? All right, so how we calculate outliers. Now, I have to be really careful with this. There is a calculation, but the calculation is totally, like, arbitrary. Like, someone just said, okay, so there are these things called outliers. We can tell by looking at a picture like that. There's some data that doesn't belong. How are we going to tell people to figure out which data doesn't belong? Well, they have to feel it. It's true. You actually have to look at your data and be like, this one, like, clearly doesn't belong for a reason, and then you have that control to throw it out. So I'm going to give you a way that we calculate it, but it's kind of like a guideline. It's not really like a strict law. Does that make sense? Like, people use this, but sometimes they decide to throw something out for a different reason because they understand their data and that piece doesn't belong. So what they do is they take the first quartile and they subtract something from it. So basically, outliers have to be at the ends, right? Extreme pieces of data. So either really small pieces of data, like if I had gone to bed at 6 p.m. and lined up with everybody, I probably would have skewed the data and like messed it up, right? So really small pieces of data or really big pieces of data. Maybe somebody went to bed at like 5:30 a.m. and slept for a half an hour or something like this, okay? Those things would skew our distribution, and we might not want to include those pieces of data if we were trying to discover like what time most students at Huntington went to bed, okay? That 5:30 a.m., if it stands out and nobody else is like that, probably needs to just be thrown out and not included, right? So to look at extremes, you're going to take the first quartile and subtract stuff. You're going to take the third quartile and add to it because you're looking for things either way below the first quartile or way above the third quartile, okay? The amount that you add or subtract, again, somebody totally just like made it up as a good amount that we could kind of check by. So again, it's kind of a guideline. It's not a strict rule, okay? But so they sometimes say what you would subtract from it is 1.5 times the IQR. Do we know what the IQR is? Good. The interquartile range. So So they basically say, if the first to third quartile takes like 20 units, do 1.5 times that. 1.5 times 20 would be 30. If you have a point 30 units above your maximum or above your third quartile, or 30 units below your third quartile, meaning that minimum is more than the entire interquartile range and another half of it away from the Q1, you don't want that point. Okay? And for the Q3, you add that same amount. Okay? So we're going to use that number, but we're also going to use it kind of like, we'll look at it. If we calculate it and we have a piece of data that's really close, but we feel like it's a valid piece of data, we can still keep it. If we look at it and we have a piece of data that we think is ridiculous, but it's technically still in the range that's okay, we can still throw out that piece of data. It's our opinion, but this will help us.
Where's the 1.5 from?
Totally arbitrary. That's why I'm saying. So then what they said is, like, you look at your picture. Let's say this extends way out here, right? This might be an outlier, and they're saying, you know why you probably know that that's an outlier? Because look how big this is. And if you take that same distance 1.5 times, and this one's further than that, it probably is an outlier. Why is it so far away from this? Okay? Bigger than this whole range. 1.5 times out there. So they just picked that. That's why it's a guideline and not a rule, because someone literally just picked it. Okay? All right, so we will continue this.